So what we're going to work on today is we're going to work on the last the last method for solving. This is the third method and the final method, and so we've gone over the graphing method. Remember where you graph the two equations and see where they intersect, or where they don't intersect, I guess. We worked on substitution, where we would solve for one variable, move everything on the other side, and then plug it into the second equation. And so this is the third method, and it's called elimination. And all of the things for substitution still apply. So, as in how we would figure out whether something was an infinite solution or whether it was a no solution. So that stuff is still the same for elimination. It's just, this is just another method for doing this. And so usually what happens is people either really like substitution and will always solve with substitution, or people will either really like elimination and always solve with elimination. So you'll just find your preference as we go through elimination to see which one you like. Rarely do people really like to graph. So, but if you do and you get the answer, you know, you're more than welcome to do that. But usually elimination and substitution are the two favorites that people use. Okay, so for elimination, there's two things you have to remember, and if you can remember these two things, you're going to be good to go, because it's almost really similar to what the substitution method is. But what makes elimination special is the first thing is you need to make sure that the front numbers for x and y, depending on what you're solving for. So see how these two guys, number one, the front numbers are the same, and then they also have to have opposite signs. Okay, here's a vocab word here, you guys. Coefficient is the official name for these numbers that are in front of the variables. Okay, it's like in number 2, 3 is the coefficient of r. Okay, so they have to have the same front number and they have to have opposite signs. So let's go ahead and look at number 1. And so looking at these, the front number, even though there's nothing written, remember you guys know that that's really 1. Okay, so let's put a 1 in front of all of these because there's no number written on there. So front number's the same. So for the x's, if you look at the x's, okay, the front numbers are the same. If you look at the y's, the front numbers are the same. And so we can choose whichever letter we want to solve for, I guess. But it has to also satisfy the second requirement, where they have to have opposite signs. So yes, the x's are both 1s, but if you look at the y's, they're both 1s and they have opposite signs, right? The top y is a plus, the bottom y is a minus. So this is the set that you want to work on to eliminate, okay? And eliminate is basically just saying that you're trying to get them to cancel out, right? Because if we have a plus 1y and a minus 1y, these guys go away, or they cancel out, so they get eliminated. And so basically what we have now is we have a 1x and another 1x, which means that we have 2 x's altogether. Then we have a 14 and a 4, which means that that's going to add up to 18. If we solve for x, divide by 2, we find out that x equals 9. Okay, and then just like what we did in substitution, we pick our favorite equation, whether it's this first one or this second one, and we plug in everywhere we see an x, we plug in a 9. Okay, so let's just, I don't know, for the sake of plugging in, let's just go to the first one. So in the first equation I have x, so instead of writing x, I'm going to call it a 9. Then I have plus y equals 14, and then I solve. So to get rid of that 9, I'm going to subtract it over. So I have y equals 14 minus 9 is 5. So I know x is 9, y is 5. So I have 9, comma 5 as my final answer. And again, if you want to double check this and see if the answer is correct or not, just plug it into either of the equations and then see how it works out. So as you guys can see, it has a lot of similarities to substitution, I guess, especially once you found the first variable and how you plug it in, it's the same. But again, so let's looking at number 1, you guys, we eliminated the x's because it satisfied both of the requirements. The front number was the same, and then we needed opposite signs. So that was given already. That was an easy one for us. But if we look at number 2, let's see. So remember, first thing is that we have to have the front numbers the same. So in the r's, the 3 is definitely the same, and the s's, okay, not so much. They're not the same because this one's 2 and this one's a 1, right? So maybe we're going to end up doing the r's, but the thing with the r's is that we have a problem because it doesn't meet the second requirement. It doesn't have opposite signs. So To get the opposite signs, what you do is choose one of the r's, so maybe this one. Let's choose the second one, the second line. And what you do to get it to be opposite signs is you multiply a -1 to everything. So there, there, and even all the way over there to the 7, okay? So what are we working with? The top line we didn't change, so it stays the same. And that's an S, not a 5. So I have 3r plus 2s, but the bottom line, because we multiplied a -1 to get it to be opposite signs, all the signs are going to change. So instead of a 3r, it's going to be -3r. Instead of a positive s, it's going to be a negative s. And then instead of a positive 7, it's going to be a -7. Okay, and now it satisfies both of the requirements that our r's are the same number, and then our signs are opposite, okay, because it's a +3, -3. It doesn't matter, you guys, if you want to solve for the r's or the s's, you just have to be good about seeing which one to eliminate. So there's not a every time, like in this one we solve for the y's because that looked like it was the easiest to solve for. This one we chose the r's because it looked like the easiest to solve for. So it's not like you always have to choose the first one or you always have to choose the second letter. You just have to be flexible and see what's going to work, okay? So if we continue on with this problem, what's going to cancel out? The r's cancel out, okay? And so what we're left with is we're left with a 2s minus an s. So we're left with that, just one s. 2 minus 7 is -5. So I definitely know for my s's it equals -5. Now I go back to the original problem, and we pick everywhere we see an s, we're going to plug in -5. So let's just work with the top equation. Might be a little bit easier. So I have 3r plus 2, and then instead of s, I know that s is -5, so I'm going to plug that in. Okay, equals 2. And if I solve out, I have 3r minus 10 equals 2. Keep solving for that r, so box it if it helps you, okay? We're going to add 10 to both sides. So I have 3r equals 12, divide by 3, divide by 3, r equals 4. So there we go. And so the question is, how do I put this into point form? Because it's not xy. You put it into point form just by taking alphabetical, whatever's alphabetical first. So the first alphabetical thing is r. So I put the 4 here. The second alphabetical thing, the next thing would be the s. So I put the -5 there. And then there's my final answer, 4, -5. Okay. Alright, I have 2 more examples just to kind of help you get started here. Looking at number 3, let's try and see if any of them satisfy the requirements here. So for this one I have, for the x's I have a 5 and a 3, yikes. But then for the y's I have 1 and 1. Okay, good. Now the y's might be easy to eliminate. Let's make sure they satisfy the second requirement. And yes, one's negative, one's positive, so we're good to go. Okay, so we don't need to multiply any number through or anything. It's good to go. So what do? I will take this and cancel out the y's. Okay, and so I have 5x plus 3x is 8x. 12 plus 4 is 16. Divide by 8. Divide by 8. X equals 2. Okay. Now you pick your favorite equation, either the top or the bottom. I just always pick the top out of habit, doesn't matter. Everywhere you see an x, plug in a 2. So 5, and then times 2, because an x was subbing it out for a 2, minus y equals 12. So 5 times 2 is 10, minus y equals 12. Let's scoot this down so there's a little more space. So remember, we want to leave the y till the very end, so I'm going to box it, get rid of this 10, so right now it's positive, so let's subtract it over. These guys cancel, so I'm left with -y equals 12 minus 10 is positive 2. I don't want a -y though, I want a positive y. So to get rid of it, let's divide by -1 on both sides. And I get a y equals -2. Okay, and so final step here is to put it into point form. Let's do it right here. X is 2, y is -2, and there we go. Okay, And so that's really the case of elimination. What I want to do is when we do number 4, the easy way to look at number 4 is to see this, right? The 6's are the same. Let's just multiply a -1 through. I want to change it up. Let's work on the D's and see how that works. Okay, so yes, this would be an easy way out. I just want to show you what would happen if maybe none of the numbers worked out. And so it doesn't matter which one you solve for, but I just want to show you an example of one where maybe all the numbers weren't the same, or you couldn't find a pair where they were the same. So if you look at the D's satisfy one of the requirements. It satisfies the requirements of the plus minus. So let's solve for the D's, and let me just show you how to do that quickly here. Even though, yes, the C's would be easier, let me show you how to do the D's. So think of a number for 7 and 2 that would be the same. 14 maybe, right? That could be a number that they both have in common there, 14, a multiple of 7 and 2. So what would I have to multiply to the second line to get 14 here? To get 14 in the D slot, what would I have to multiply? I'd have to multiply it to 2, right? And if I had to do that to the second example, what would I have to multiply to this 2 on the bottom here to get 14? I'd have to multiply a 7. So here we go. We're going to go here, here. You're multiplying these to everything in the line. So in the first line, I'm multiplying a 2 to everything. 2 times 6 is 12. 2 times 7 is 14. 2 times -15 is going to be -30. On the bottom line, I have 7 times 6 is 42. 7 times -2 is -14. 7 times 12, let's see what that is. I need to work that one out. 4, carry the 1, 84. Okay, so now let's solve. So again, we're good to go because we got these 14s to match up and they're both plus minus. So the key thing is plus minus. Make sure they're plus minus. People always remember about the numbers having to be the same, but they forget about the plus minus. So at this point, since we've gotten them to, they've satisfied both of the requirements, these can cancel out. And so now all we do is we simplify. 12, and this should be a C, sorry. So 12C plus 42C is going to be 54C. Okay, equals, and then we have 84 minus 30. Let's take this to the side and figure that out. Okay, so we get 54. Okay, so we got 54 in there. Divide by 54, divide by 54. So C equals 1. Okay, now what we do is we go into one of the equations. Remember, solve. Everywhere you see a C, plug in a 1. So we're going to go to the original equations, okay? So I have, if I go to use the first equation, I have 6 times 1, plus 70 equals -15. Scoot this down here. I have 6 plus 70 equals -15. Let's move this -6 over. And I have 70 equals -21. Divide by 7. Divide by 7. Cancel. D equals -3. Okay, so again, just because it's XY doesn't mean I can't put it into point format. You just put it in alphabetical order. So C comes first, so the 1 goes there. D comes next, so it goes in the second slot. Final answer is 1, -3. So again, you guys, there could have been an easy outlet on this if we just did a -1 through this problem and just got the 6's to just be opposite signs. But I wanted to show you because sometimes some of the examples will have none of the numbers the same. And so you'll have to multiply and be creative. So I was trying to show you how to do that in this number 4. That's why I worked on the D's. And so if that happens, you'll have to think of a common multiple that the two numbers have. Like in this case, 7 and 2, they both have a common multiple of 14. So that's what my goal was, to solve them. So hopefully, though, they work out like how we had been doing for 1 through 3, where they're opposite signs or they're same number already. But just in case, number 4 is a good example to refer to. Okay, so that's it, and don't forget to take the quiz.